Okay, gonna do the example now. There's 4 parts, but before we do the 4 parts, we're gonna do this introduction question first. Find the 5 roots of z to power 5 equals 1 and plot them on the complex plane. Now, what this means is there's 5 roots and equally spaced, and it forms a regular polygon. Okay, so what's a full circle is 360, which is 2 pi, and if you equally space it, it'll be 2 pi over 5, wouldn't it? So there'll be a 2 pi over 5. There's a 5 of the roots on the plane, and it will form a regular pentagon. Okay, so the one that I've just done, it'll look like this. I'm sure you can do a lot better than this one using careful structure. Mine's not as a regular pentagon, but just think that it is, because each one of them is spaced in 2 pi over 5. Okay, now that's a Z1, and this is what we call as a row in the Greek alphabet. So row to power 1, row to power 2, row to power 3, row to power 4, row to power 5. Okay, that's the same as a Z1, Z2, Z3, Z4. Now these two are conjugate, and these two are conjugate. So these are because of the argument is from minus pi to pi. So we can't keep going. You have to have a conjugate pairs into the third and fourth quadrant. Okay, so I'm going to put this away. So that's what's happening. And part A, let's have a look. If rho is a complex root of z to power 5 equals 1, explain why the sum of the roots is 0. Now, if you think about it, do you remember with the polynomials, z, I'm going to write something here, yeah, z to the power 5 minus 1 equals 0. So it means z to the power 5 plus 0 z to the power 4 plus 0 z to the power 3 and so on, and then minus 1 equals 0. Now the sum of the roots is minus b over a. We know that b is going to be 0, a is 1. So the sum of the roots will be 0. So therefore the sum of 0 equals 0. Okay, that was a simple one. And I'm just going to put the next question on top. Yep. So factorize z to the power 5 minus 1 into 1 linear and 2 quadratic factors with the real coefficients. Okay, so we need to write it into some sort of form of 1 linear, 2 quadratic. Okay, so there's a factor forms of 3 factor forms. Okay, so let's have a look. I'm gonna put it in here. Z to the power 5 minus 1 equals, I know I'm going to get z minus 1 from the diagram, the one that I just showed you before. So I'm looking at, there is the z minus 1 here, z minus 1, okay, and here I have z minus rho, and then next one I have z minus rho squared. Now this part, this 2 is conjugate, so need to be careful, but let's just write it as what it is, cube z minus rho 4. So we got 1, 2, 3, 4, 5 vectors. Okay, now these ones we can change that because since it's a conjugate pair, so I'm going to change this one minus 12 squared conjugate of. Okay, so then we can put these into the form. So I'm going to do that right now. So this one was z minus rho. I'll just write it as it is first. Squared cube. Oops, can't see. And I'm going to tidy it up with 1 row. That was okay. Up to here was okay. Now we're going into conjugate pairs here. Minus so we got 1, 2, 3, 4, 5. Yep. So that's pretty good. And then we can sort of expand this one. So what I'm going to do is I'm going to leave this one as it is, but could have been better if I just do that and then do this one together. So I will get, definitely will get quadratic, isn't it? If I times this together and I times this together, I'll get quadratic. The reason I'm timesing this together because they are conjugates, so it'll be a lot easier. So I'm going to do these two first. So it'll be z squared minus, remember second term is the sum of the roots, and the third part is the product of the roots. So that's what I'm going to do. The sum will be rho plus conjugate. And then I'll times product of the roots. So that's these two together here. And I'm going to just times that one together now. Minus square plus rho squared z plus, oops, can't see, okay. So now we need to find what this, we can replace this to, so we're going to have to separate this. So I'm going to do 1, 2, 3, 4. Okay, so let's have a look. I'm going to push this one up. So let's deal with rho plus conjugate rho. Okay, now when we calculate this one, we need to put it in a polar form. Okay, so I'm going to go, the rho will be cos 2 pi over 5 plus I sine 2 pi over 5. Okay, so that's the rho one. And the conjugate will be cos 2 pi over 5 minus I sine. Always conjugate pair is the changing a sign on the imaginary part. Okay, I'm going to push this one a little bit. And if I do that, I'll cancel this together. I'm left with a 2 cos 2 pi over 5. Okay, so that's what we got. That's the first one. And then second one was the product, wasn't it? So rho and conjugate rho. So if I 2 pi 5 plus I sine 2 pi over 5, and then I times it, cos 2 pi over 5 minus I sine 2 pi over 5. Okay, so that's what? Difference of two squares, isn't it? So if I get that, I'll definitely get to square, really. minus, but because I times I becomes plus, because I square equals minus 1, isn't it? I square is minus 1, so this becomes plus. Yeah, so I'll go sine 2 pi over 5. Now this is first trig identity, the cos square theta plus sine square theta equals 1. So that becomes just 1. Okay, just remember that. Now 3 will be the rho square plus rho squared. Okay, so what's that going to be? That's simple, because all you have to do, if it's a square, so de Moivre's, it'll become 4 pi over 5, not 2 pi over 5, 4 pi. So I'm going to do exactly the same as the previous one, but instead of 2 pi, we've got 4 pi over 5 plus I sine 4 pi over 5. Let's see if I can write a little bit smaller, plus cos 4 pi over 5 minus I sine 4 pi over 5. Even you can't see the last bits, let's see if I can push this one. Yep, and then I can cancel these and I will get 2 cos 4 pi over 5. Yep, that's what I got. And then the last bit of it is the product part, times, now that will be difference of 2 squares again up to here, and then we will get the first trig identity, which will be just 1, because it'll be just cos 4 pi over 5 squared plus sine 4 pi over 5 squared, so it'll be just 1. Okay, so I've got those. So now all we have to do is just put those all four things that we actually calculated, solved into all this spot here. Okay, so I'm going to do that now. Let's see if I can actually write it a bit smaller so I can fit all in one go. So I'm going to write it very small. Z to the power of 5, 1 equals Z minus 1, that's 1. And I'm going to go Z square minus, now what was the row plus conjugate row was 2 cos 2 pi over 5, yeah, and that was that, and Z, yep, and then plus the product of the row and the conjugate row was 1, so I'm going to do that. So this is the linear factor part, 1 linear, and I'm going to have to write the second part. I'm going to move this one a little bit. I can write the whole thing in one space there. So next one is Z square minus, now this is a row square plus conjugate row squared, so which was, I'm going to put this in 2 cos 4 pi over 5 Z plus 1. Okay, so that's what we got to get. So that's the answer to part B.